Hi YouTubers, once more, Uncle Pythagoras returns back to explain more about the function. The previous video we were talking about how the function is mapped. It maps the elements of the domain and the element of the range. Now we want to find out why we call a function and why we call it is not a function. Right, we are still in the inverse functions. Here we are going to do the following: how to determine if a graph is a function or not a function. 2. What type of a function, if it qualifies to be a function, and which method do we use to test whether it is a function or not. Now we are going to take the example from the previous video where we had f at x. Let's say this is our example. We can call it example 1. We have f at x is equals to 2x plus 1. Now this is what you are given as a function. They want you to understand, to determine if this graph of this function is a function or not. Now we can plot this graph in the following way. For x-intercept, you let y to be 0. Then f at x is the same as y where you see y, you put a 0. 0 equals to 2x plus 1. Then 2x is equals to minus 1. Then x is equals to minus half. Then you need to find the y-intercept. You let your x to be 0, then f at x is your given function, which is 2x plus 1. You want to find the value of y. Y is equals to, whenever you see an x, you put a 0, which is y equals to 1. Now let's draw the function. Let's draw the graph of this function. This is your x-axis, and this supposedly it's your y-axis, right? You have your 1, 2, 3, 4 for the y-axis. You have a minus 1, minus 2, minus 3, and so on. Minus 2, minus 3. Then you have a positive 1, positive 2, positive 3. Right, let's grab the 1. X is half, minus half. Here is minus half. Our minus half is going to be right here. Rather, let's call this 0, 1 over 2, and then this is going to be 1. This is going to be 1.5. Then this is going to be 2. for convenience sake. This is going to be half 1, 1.5, 2, right? This is going to be half 1, 1.5, and so on. This is half, this is 1, this is 1.5, and so on. This is 2. Right. We have found that x is equals to minus 1. Here is your minus 1. Your x is minus half. Here is your minus half. And then your y is 1. Your y is 1. So the graph is going to move like this. Let me just, for convenience sake, your 1 is up there, and then your half is this side. So we don't have to draw it to scale for convenience sake, because we need to explain another concept which is very, very important. Now let's say our minus 1 is here. Our minus half is here. Then our 1 is here. Then I need it to have a full scape of the space so that we will explain something that is very clear. I need it to be clear. For clarity's sake, this is our graph. Right. This is our graph of f at x is equals to 2x plus 1. Right? Let's check something here. We want to determine whether this graph is a function or not. This is what we are going to use. Point number 1. Point 1. We are going to use what we call a vertical test. A vertical test wants to determine, it determines whether the graph is a function or not. Once you find that the graph is a function, then you can go and determine point number 2 by using a horizontal test. A horizontal test determines whether a function, a graph rather, is a 1, 2, 1 or a many to 1. I don't have a space there. We determine whether a graph is a many to 1 or is a 1 to 1. It's a many to 1. I can squeeze many to 1 right here. A many to 1. Yes. This is what I want you to go through with me to see if, right, to explain more things here. If you determine by a ruler, you are going to use your ruler in your graph to determine the first point, which is a vertical test. If the vertical test passes, then you go to determine the second test. You are going to use a horizontal. By using a ruler, you're moving it up and down. Then by vertical, you're moving left to right or right to left. Then you determine whether it's a function, and if it is a function, what kind of a function is it. Right, let's start with 1. It's a vertical test, right? We are going to move your ruler along your graph. As the graph is moving from left to right, you can see that 1 is mapping it maps one value of x to one value of y. You can see that one value of x here goes with one value of y and one value of x, and here it goes with one value of y maps one value of x. So that, what does that mean? It means that this is a function. What kind of a function is this? This is a, that it qualifies to be a function. Then you can say that therefore 1 the graph is a function by using a vertical test. Number 2. Now we're going to use a horizontal test. This is going to determine whether the graph is a 1-to-1 or a many-to-1. Before I can go and do this horizontal test, let me just simplify or clarify something here. When this vertical test does not qualify to be a function, therefore the graph is a function. If it is not a function, you don't go and do point 2. That's it. It does not need you to find whether it's a 1-to-1 or a many-to-1, because it already qualifies to be not a function. Now let's go for number 2, because we have identified that this is a function. Now let's check if in the horizontal is going to tell us it's a 1-to-1 or many-to-1. This goes with what? A horizontal test. You're moving it up and down. As you can see, the ruler moves from up and down. It touches one value of x and one value of y. It means that it's a what? It's a 1-to-1 function. Now you come and say, point 2, by using a horizontal test, we have found that that the graph is a 1 to 1 function. We have discovered, I left this space because it's a little bit wet. I wait for it to be. We have discovered that the graph is a 1 to 1 function. We are done with a 1 to 1 function. Let's go for another function which will yield up to something else other than a 1 to 1 function. We have spoken about the graph of f at x is equals to x squared. And when we tabulated the values here, we have found that the value of, if we put x here, f at x is going to be 1. When we put a minus 1 here and 1x, when we put a minus 1 here, you get y is 1. When you put a 1 here, you get y is 1. Now, this is a many to 1. But we need to find out by using these two methods of test. We start by drawing the graph first. The graph is going to be not according to scale, by the way, not according to scale. Right? This is our x-intercept, x values, by the way. This is our y values. Now, this kind of value is going to go like this. This is the function of f at x equals to x squared. Now, if you come to test for 1, what is a 1? It's a vertical test. We are coming to test if it is a function or not. When you move your ruler in a vertical way from left to right and vice versa, from right to left, you are going to find out that this touches a value at only 1 point. The graph is being touched at only 1 point. Therefore, it is called a what? We find that the graph is a function. Number 2, we come to use the horizontal test. What do we find about the horizontal test? Here it says a horizontal test determines whether a graph is a one-to-one or a many-to-one function. So we are coming for horizontal. Here we come, we start here at 0, it's one-to-one, we are here, then we move, we find that it is, there is something that I want to show you, grade 12. This is it won't be as perfect because it's not drawn to scale. Right, as I move my ruler, from up, from down to up, or up to down, I find that there is two values that I find from the domain, but only one value that I find in the range. Similarly, it can be applicable here. You can also do the same thing here. You can find the same thing. It is not drawn to scale, but you can see that there are two values which are going to map only one value of y, and there are two values of x here in the lower case that are going to map one value of y. What does this tells us? This is a many to one function. If you can check this, if you say this is minus 3, for instance, for practical reason's sake, this is going to be a 9. When you put a 3 here, you square a 3, you are going to get a, this is a positive. You are going to get a 9. This is just a roughly sketch. Therefore, the function, the horizontal test, we discovered that a graph is a many to one. Now let's go for the last part of the puzzle, whereby we find that it is not a function. How do we discover that a function is not a function? By the same way test, the same horizontal test, this one is a 1, 2, 1. This one is many to one function. This is a one-to-one function. Now, remember the previous video, we have grabbed the very same function and alter it into a what? Into an inverse. We take the inverse of the parabola. Our parabola was in this form. And then we make the inverse of it, which is f at. Let's take it step by step so that you will see it. Remember, this is y is equals to x squared, right? So in order for you to find the inverse of this, you are going to simply swap the values. Where you see y, you put x. Where you see x, you put y. And then y squared is equals to x, and the square root of y squared is equals to the square root of x. Immediately you apply the square root, you put a plus minus. This is also a plus minus, but when you cancel here, you are left with y is equals to a plus minus a square root of x, provided that x is a positive number or it is equals to 0. Therefore, this is the inverse function in the form of f dash x is equals to a plus minus a square root of x. Right. If we draw this kind of a graph, we are going to find that we tabulate here. The value of x here is going to be, when x is 0, your y is 0. When x is 1, y is plus minus 1. When you put your x here, you're going to get a 0. When you put your 0 here, but when you put a 1 here, you're going to get a plus or minus the value of y. So we have two values of y here. We have one value of x. Now let's sketch this graph. Now let's come and plot 0 is to 0, 1. We find the value of y of x here, it's 1. The value of y here is positive 1 and negative 1. Where do they meet? Now, The value of y means here, and then here -1, +1. Then we have a graph that goes like that. It comes this side, it goes like that. This is the type of graph we are going to find. Then this is f at x, f dash x is equals to plus minus square root of x, provided that x is greater or equals to